All right, so in this video, I'll go through question 6 and 7 from the short answer, and then question 19 from the multi-choice. All right, so parcel deliveries are made between 5 nearby towns, P to T. The roads connecting these nearby towns are shown on the graph below. The distance in kilometres are also shown. A road inspector will leave from town P to check all the roads and return to town P when the inspection is complete. He will travel the minimum distance possible. How many roads will the inspector have to travel on more than once? So there's a few ways to go about this question. You can do a bit of trial and error where you try and get through as many as you can and then see how many you have to double up before you get back to P. So you can do it that way. That's fine. It's a bit more tedious. The way I would try and go about this one is to try and think about, all right, if this person's going to travel on all of the roads and they want to get back to where they started, that's an Euler circuit. Now, for an Euler circuit to exist, then we need all even vertices. At the moment, P, Q, T, and S are all odd. So we can kind of think about it that is, okay, if we added in, like, say, another two edges, another one here and another one here, what that does is that makes every single vertex even now. And this way we would be able to get to every single road and return back to P. So if we were to add these two rows, basically another way of doing that is to double up on the road between P to Q and the road between S to T. So therefore, the inspector would have to travel on two roads more than once. You could also do the same between P and S and Q and T or whatever, but for that to exist, he'll have to travel on the road, two roads more than once. So yeah, as I said, you can do a trial and error as well. So just go right round and realize that you have to double up on two roads, which is a bit more tedious. Or you can identify that the mathematical term there is the Eulerian circuit. So therefore, two roads will need to be doubled up due to the degree of the vertices. Determine the minimum distance in kilometres that the inspector will travel. All right, so this kind of goes back to the drawing we've done up here. Because we're needing to double up on two of the roads, it's either going to be the roads between P and Q and S and T. Now, if we want a minimum distance, we want to choose the one that's going to get us the lower values. If we were to double up on 10 and 12, that adds an extra 22 to our total network. If we were to double up on the 14 and the 20, that's going to add 34. So the 10 and 12 is a much better way to go about it. So what we would do here is add up all the numbers in the network and then add 10 and 12 again to get the overall. So if I write that out in full, oops, I've got. So that's all the roads, and then we're doubling up on the 12 and 10. All right, so what's that? 10, 30, 42, 56, 62, 69, 77, 86, 98, 108. Hopefully my mental maths is correct there. All right, so for this one you asked for 7C help, but we'll go through the whole thing. 5 musicians are to record an album. This will involve 9 activities. The activities and their immediate predecessors are shown in the following table. The duration of each activity is not yet known. All right, so with this one we need to go through and, finish off the critical path here, or the whole network, sorry. All right, so coming off of D and E is G. Coming off of F is H. That's going to connect up here. And then coming off of those two is I. All right, there is only one critical path for this project. How many non-critical activities are there? All right, so looking at this network, we have 9 activities in total for A to I. Now, we don't know where the critical path is yet. It can either be A, D, G, I, B, E, G, I, or C, F, H, I. It could be any of those. Now, the thing about all of those potential critical paths is they all involve 4 activities. What that tells us is that no matter which one of those is the critical path, there's going to be 5 non-critical activities because every time there are 5 activities not included in the potential critical path. So if, say, for it's A, D, G, I, that means that B, E, C, F, and H are all not critical. If it's B, E, G, I is the critical path, then A, D, C, F, and H are not critical. So no matter what the outcome, it's always going to be 5 non-critical activities. Then for 7C, the following table gives the earliest start time, and later start time for 3 of the activities only. All times are in hours. Write down the critical path for this activity, for this project, All right, this is a pretty tricky question. What you need to acknowledge here is that with each activity, the earliest start time and latest start time is the same when they're on the critical path. So we definitely know that I has to be on the critical path because the earliest and latest start times are the same. Because A and C here is times for their earliest start time and latest start time, they're different. That means that they are not on the critical path. So just looking back at the network up here, A and C aren't on the critical path. That literally only leaves one possible option for the critical path. Has to start with B, so meaning it has to be B, E, G, I. So if you get a question like this, you need to understand that the earliest and latest start time has to be the exact same for activities that are on the critical path. All right, and then 19 from multi-choice. Aaron, Boris, Charlie, and Dan work in an ice cream shop. Today, each worker will complete one of 4 tasks, 1, 2, 3, and 4. The usual completion time for the workers is shown in the table below. Boris takes 3 minutes for task 3. He takes K minutes for each other task. All right, so task 1, 2, and 4, they're all taking the same time for Boris. We just don't know what that value is yet. The store manager allocates the task as follows. This allocation will achieve the minimum total completion time if the value of K is at least. All right, this is a hard question, and it will take you a pretty long time in a SACA exam. We are going to have to do some row and column reduction here to solve it. First step is to work out what the current allocation is. So what we need to do is work out the time that this allocation gives us. So if Dan does task 1, that's a time of 4. If Aaron does task 2, that's 3. If Boris does task 3, that's 3. And if Charlie does task 4, that's 2. So the total completion time here is 12. So what we need is the smallest possible value in here that gives an overall completion time of 12. If it's any lower or higher than that, we are not going to include it. What you would do here is you would need to test the smallest value first. So 0 is the smallest possible option. What you would do is put 0 for K for all of these. You would then do your row reduction, possibly your column reduction if you have to do both, and work out what the allocation would be then, the optimal allocation. Just for time's sake, I won't do it, but if you do your row and your column reduction, possibly drop your bipartite graph as well, what you get is a allocation time of 10 minutes. Now, that's not what we want. We need it to be 12. What you could do is you could go right through those options and do the exact same process for 1, 2, 3, and 4, but that's really tedious. What I would do now is say, because 0 gives you a time of 10 minutes, what that means is that if you substituted in 1, it would give you 11 minutes because you're adding 1 to the K value, would add 1 to the allocation time. With that logic, if we substitute in K equals 2, that would give us a minimum allocation time of 12 because 2 is greater than 0. So the answer for this one is C. If we substituted in K as 3, which is the D option, that would give us our allocation time of 13. If we substituted in 4 for E, that would give 14. So what you really need to do here is to test one of them and then adjust your value accordingly. So typically it's best to start with the smallest one, so in this case 0, work out the allocation time. If it's too small, then you need to just increase it by whatever the value is you need to increase to get to the minimum allocation. Hopefully that clarifies a little bit. If you do want some extra help, please reach out.